this problem right here. How many of you finished this problem? 3 plus 2i times 3 minus 2i. Well, let's go through it and see what happens. Because this, remember, this is a number, this is its complex conjugate. And I said when you have these, you multiply them together, something really nice happens. So when I have 3 plus 2i times 3 minus 2i, I have, and when I FOIL it, 3 times 3 is 9. 3 times negative 2i is negative 6i. 2i times 3 is plus 6i. And 2i times negative 2i is minus 4i squared. So what I have now, the negative 6i and the positive 6i go away. So I have 9 minus 4 times, what's I squared? Negative 1. So I have 9 minus 4 times negative 1, which is the same thing as 9 plus 4, which is 13. What happened to all my i's? They went away. When you multiply a number times its complex conjugate, you no longer have any complex part or any imaginary part. You are left with a nice real number. So when we do division, we are going to use the concept of complex conjugates to essentially rationalize the denominator. So when I want to rationalize the denominator, to divide 3 minus 2i by 4 minus 5i, I'm going to need to multiply the denominator to make it nice and real by its complex conjugate. So it's going to be 4 plus 5i. If I do something to my denominator, what else do I have to do? I have to do it to the numerator. Otherwise, I change my problem. So I'm going to have to multiply my numerator times 4 plus 5i.
Wait, where did you get the 4 plus 5i?
It's the complex conjugate of the denominator that was given. The idea behind division in complex numbers is to make the denominator into something that's real. And the way to do that is to multiply by the complex conjugate of the denominator. All right, so let's do our multiplication. I have 12 plus 15i minus 8i minus 10i squared. And in my denominator I have 16 plus 20i minus 20i minus 25i squared. Now if I put everything together, yes? Yeah, just down that end of the building is a quick way. That way and left. Put everything together that's in common, so I'll have 12. 15i and a negative 8i leaves me with a positive 7i. Negative 10i squared is negative 10 times negative 1. And in my denominator, I have 16. Positive 20i and a negative 20i. That was supposed to happen. And then I have negative 25 times I squared, which is negative 25 times negative 1. And that will lead me to, in my numerator, I'll have 12 plus 10, so 22, plus 7i. And in my denominator, I will have 16 plus 25, which gets me 31? 41. 41. Now for web work, remember you're going to have to do a plus bi form. What's going to be a for this problem?
22 over 41.
This 10, negative 10 plus the negative 1 became a positive 10, and I added it to 12 to get to 22. So what was the answer I heard somebody say?
22 over 41?
22 over 41. So I take the part that doesn't have the I with it, and I make sure to include 41. The denominator, the correct one, too. So 22 over 41. What's the B part?
7i over 41.
Is there an I? Just the 7 over 41.
Oh, 7 over 41.
Because remember, the B is the real number in front of the I. So that was the last thing in that section. We're not going to get